All right, guys. So I'm going to do lesson 5, 6 today. The title of the lesson in the book is called "The Fundamental Theorem of Algebra." Sure sounds important. But anyways, the learning target, a little more specific, says I can find the number of roots a polynomial has. So that's kind of one thing. Understand how many roots it has, and then also use the rational roots theorem. Honestly, we don't really use that much in this, but we kind of you could use the rational root theorem. More so, we kind of use synthetic division to help ourselves find all the solutions. And remember, kind of types of solutions we could have. The easiest are like integer solutions. Those can easily be found on the graphing calculator. How do roots of a polynomial function show up on a calculator on the graph of a function? What part of the graph represents like a solution or a root or a zero? The x-intercept, right? You have other ones that are a little bit more difficult to find. You can have rational numbers that are like a fraction, so like 1/2 is a little bit tougher to find. You have irrational numbers. You even have imaginary numbers, right? So all types of solutions. We'll touch on some of each in our 3 examples today. But first, kind of starting off with a simple idea here: this fundamental theorem of algebra. It states that if p of x is a polynomial whose degree is at least 1, then the equation p of x equals 0 has exactly n roots, including multiple and complex roots. So basically, that's a mathy way of saying, a second degree polynomial has 2 roots. A fifth degree polynomial has 5 roots, right? The degree of the polynomial tells me how many roots it has, which we've already kind of touched on that idea a bit. On that note, example 1 wants to know how many roots does the equation 12x to the 5th plus 3x squared minus 17x to the 10th equals 0/2. So real quick, no calculator or anything else. What degree is this polynomial? 12x to the 5th plus 3x squared minus 17x to the 10th. What would my degree be there? What is it? It's higher than 5th degree. So what are we missing? So what would it be if it's not 5th degree? 10th degree, right? So my highest degree term, even though it's written in the back, does determine my degree, right? So this term right here says it's a 10th degree polynomial. And according to our theorem, it has 10 roots. Okay, so 10 roots. All right. So to find rational roots, you must use, or it says you must use. Let's say you can use synthetic or long division. We'll probably use synthetic because it's quicker. Whenever you get a remainder of 0, you have a solution. Okay. So that kind of sums up what we're going to do. But we're always going to start by kind of thinking about 2 things when we're solving one of these equations. So in all of our examples today, we are going to just try to find all the roots. Okay. So looking at A, we know right off the bat we should have 3 roots because it's a 3rd degree. Okay. I would always look to and think, could I factor this? Could I solve by factoring? There's no GCF at the beginning for all 4 terms. We couldn't really factor by grouping, so probably not. Okay. Once you've determined that, then we can kind of go into our process. Hello. Which would be, go ahead and type it in. Go ahead and type it in and see what kind of x-intercepts we see. So 15x to the 3 minus 32x to the 2 plus 3x plus 2. That doesn't look right. I think I typed something in wrong. Oh, I typed that in on my home screen. Weirdo. Let's go to y equals and type it in where we type in a function. Sorry about that. Try again. X to the, is it Monday or something? 15x to the 3 minus 32x to the 2 plus 3x plus 2. So you know what they say, the 8th time's a charm. So now let's look at the graph. And I always do start by looking at the graph. So looking at the graph, I can tell that I have 3 real roots because I have 3 x-intercepts, right? And it looks like there's one that might go through the origin, 0, 0. It looks like there's one between 0 and 1, and it looks like there's one at 2. You always want to confirm by looking at the table. So maybe we have easy ones at 0 and 2. Does everybody see what I'm looking at there? That kind of makes sense. So now we go to the table. And when we go to 0, we see that that was close to being a 0, but not quite. 0 goes to 2. 0 doesn't go to 0. So that's going to be some other number that's pretty close to 0. Let's check out the 2. And that is our one easy 0 that we can just pull from the calculator, right? So it goes through 2, 0. So I know that's one of my 3 roots, one of my 3 real roots. So from our calc, we see that it goes through 2, 0. So we can say x equals 2. So that's one of 3. All right, so now how do we find the other 2 exactly? Okay, one way that we can start to pare down that cubic, knowing that we have a solution of x equals 2, is to use synthetic division. So that's what I would recommend doing from there. So let's divide the solution 2 into the polynomial 15 for 15x cubed minus 32 for negative 32x squared, positive 3 for x, and positive 2. So remember this process. Bring down the 15. Take 2 times 15 to get 30. Add to get negative 2. Multiply to get negative 4. Add to get negative 1. Multiply to get negative 2. Okay, now, if you think you're dividing by a solution, you should always have that 0 at the end. If not, you've gone wrong somewhere. You've either seen it wrong on your calculator, you've divided wrong, something's gone wrong. So you got to check for a mistake. We did get a 0, so we know we're in good shape. Okay, so now we think about what we have here. Anybody remember what exactly that means that I have highlighted there? Or what that would, how I could write that out as a polynomial maybe? What would that first term be? 15 what? What's that the coefficient of? X squared, right? You always go down by 1 degree. So that's 15x squared minus 2x minus 1. If that wasn't obvious to you, maybe you write that out, because that. Okay, so basically my other two solutions are going to come from this equation right here. Okay, so I would just say at that point, probably the easiest thing to do would be maybe use the quadratic formula. You can also check to see, could I factor this? You know, is there a combination that adds to negative 15 and multiply, or sorry, I said that wrong. Multiplies to negative 15, adds to negative 2. I think we could use 5 and 3. So you could factor, you could use quadratic formula. If you know you would use quadratic formula, why don't you go ahead and show it that way on your notes to get these 2 solutions? I'm going to show it by factoring though, because you can factor, just to show you a different way. Okay, but if you know, if this were a test, I'm using quadratic formula, go ahead and finish it up that way. See if we get the same 2 solutions, okay? Or if you want to follow along, here's how it would look by factoring. So we could split up the minus 2x in the middle as negative 5x plus 3x, because those 2 multiply to negative 15. Out of the first 2, we could pull a 5x. That would leave me with 3x minus 1. And then out of the second pair, we couldn't pull anything. So plus 1 times 3x minus 1. And so my two factors are 3x minus 1 and 5x plus 1. And we could just use the zero product property to get our last two solutions, which are, it does make sense. I'm just messing with you, Eli. Did you have a question, though? Okay. All right. So if you're using quadratic formula, you should end up with the same two solutions as I. You get 10 over 30, which goes down to 1/3, and negative 6 over 30, which goes down to negative 1/5. Okay. Which I got by factoring, but it doesn't really matter how you get there as long as you get there. You can see those are rational solutions, but you can't really get those from a table, can you? Because we only can find integer solutions that way, right? So just to summarize there, we have three solutions. One of them was super easy to find from our graphing calculator. The other two, we had to do a little bit more investigation. So just to recap, we have three solutions, one at negative 1/5, one at 1/3, and one at positive 2. All right. So any questions? Now, how you could use the rational root theorem here is, and you see I kind of just skipped that because I don't think it's very efficient. But once you have like the 2 from your calculator, two of our rational roots would be, plus or minus 1/5 and plus or minus 1/3, and then basically you guess and check till you get a remainder of 0. To me, that's just inefficient. So once I get my quadratic, I'm using quadratic formula, factoring something else, okay? All right, let's do one more together, okay? Looking at B, we have another cubic polynomial, so we're looking for, again, 3 roots. Let's go ahead and assume we can't factor, which we can't. So we'll go right into type it in under as a function rule. So y equals 2 times x to the 3rd minus x squared plus 2x plus 5. And again, I don't go right into the table from there. I want to get a visual of, does it look like I have any x? So I know where to look in my table, okay? So I always look at the graph first. And it looks like we have kind of maybe one, hopefully easy x-intercepts. Does it look like it's going to have any other x-intercepts? Doesn't look like it, right? We could zoom out to be sure, but it looks like no. Assume we don't, and we don't here. What's that tell me about my other two solutions? If they don't show up as x-intercepts, what kind of numbers are they? If they're not real numbers, what are they? Complex or imaginary numbers, right? So that can happen too, and that's what's going to happen here. Let's go ahead and look in our table, though. Just confirm that negative 1 does go to 0, and it does. Okay, so that's 1 of 3. And if that's all you can come up with on a test, that's better than nothing, right? So from our calculator, we see that it goes through negative 1, 0. So x equals negative 1. And again, that would be 1 of 3. All right, so we go ahead and start to divide and pare down our cubic into a quadratic. Okay, so we're taking negative 1 into 2 for x cubed, negative 1 for x squared, 2 for x, and 5 as the constant. Then we'll go ahead and do our process. So bring down the 2. Multiply to get negative 2. Add to get negative 3. Multiply to get 3. Add to get 5. Multiply to get negative 5. And there's that 0 we were looking for. If you understand that this is a quadratic, and you kind of understand that it's going to be funky solutions like imaginary numbers, you don't even really need to write it out. But if it helps, you can. You could just understand that this is A, this is B, and this is C. Okay, in our quadratic formula. Okay, so I'm going to do that over to the side. We have x equals negative b, so that's negative negative 3. Plus or minus the square root of that discriminant. That's that b squared minus 4ac part. So under my radical, I have negative 3 squared minus 4 times 2 times 5. And then it's over 2 times a. So in this case, 2 times 2. Now we start to pare it down a bit. And negative negative 3, of course, is positive 3. 2 times 2 is 4. And let's, just so we don't make any mistakes, kind of think about what's under the radical. You do have to be careful here. So I kind of showed a common mistake. Some people type that in with the radical. So if you type it in as 3 squared minus 4 times 2 times 5, it's going to say error. That's because that's an imaginary number, right? So what you want to do is type it in as 3 squared minus 4 times 2 times 5 and see that that's negative 31. Okay? Then we can deal with it from there on our own. So my discriminant is negative 31. And so these are my last two solutions right here, but I just want to clean that up. Okay, I want to clean that up. It should be some number involving I, right? So that's going to be 3/4 plus or minus. That's where I get the two solutions. How do I clean up the square root of negative 31? How do I formally write that out to make it like a final answer on a test? Anybody remember from the last test? Yes? Put what on the outside? I, yep. And then you think about, can I reduce the square root of 31 down? You can't. So yeah, just we'd say square root of 31 over 4 times I. Or I square roots of 31 over 4. You could write it down either way. So there's my last two. And there you go. So I have one real solution, x equals negative 1, which we found on the graph, and then two complex solutions, which we're not finding without algebra, right? So anyways, hopefully that helps. Looking at C, I'm going to have you guys consider this one in a minute. Before we do, just some simple facts. How many solutions are we looking for total on C? 4, right? And they might be real, they might be imaginary, but we're looking for 4. Okay, so on that note, we may have to do more than one synthetic division, and you will. Okay, so you'll divide and you'll divide again. Then you'll have a quadratic. Anyways, try your best. I'll work it out in about 5 minutes, but this will help you to know what am I getting, what am I not getting, and I'll show it in a few minutes. Okay. Give it a shot. Work with somebody around you, that can be helpful. All right, guys. Here in about a minute, I'll kind of, well, I guess I could start to go over it now. Is anybody still kind of working through it, or? Yeah, let me give you that last minute. I'll kind of take it from there. Good job working through it. Still wish y'all talk to each other a little bit more, help each other out, but. All right, guys. So go ahead and just kind of go over it real quick. I'll write the answers up first, and then if you have it from there, feel free to, obviously you have it, feel free to tune me out and get started on the homework if you like. If not, I will go through it. So what we can see initially right off the bat is two of our four solutions appear to be real numbers and hopefully easy. It looks like -3 and +3. So then we'll confirm from the table. -3 goes to 0. Good, right? +3 goes to 0. Good. Now we have two, like I said, of 4, right? Not only do we have that, we have two numbers we can divide by to get it down to a quadratic, right? So from our calculator, we have x equals plus or minus 3. And again, that's 2 of 4, right? It also appears that the other two aren't going to be x-intercepts, right? And here's where that end behavior thing can kind of come into play. This acts like an upward-facing U because it's even, right? So it's going to finish up and up. So that tells me not going to come back down anywhere, right? So our last two are going to be imaginary, right? This is all good stuff to know. Anyways, the last two are x equals, let's see, where are they? -1/2 plus or minus square root of 7/2, sorry, 7/2i. Okay, if you got all four of those with no help, I'd say go ahead and tune me out and start on the homework. If not, though, kind of watch me work through this. I'll go quick, okay? So the only way we're coming up with the blue ones is to divide by both the -3 and the +3. Okay, so you just go part by part. You could start with whatever with whichever one you want. Words are hard sometimes, you know. So I'm taking -3 into 1, 1, -7, -9, -18. Start by bringing down the 1, and then you go through it. -3 times 1 is -3. Add to get -2. Multiply to get 6. Add again, -1. Multiply again, we get 3, and then add to get -6. Multiply to get 18. There's our remainder of 0. Got to have that, okay? Then we can divide 3 into that one, that cubic. 1, -2, -1, -6. Bring down the 1. Multiply to get 3. Add to get 1. Multiply to get 3. Add to get 2. Multiply to get 6. And another check mark, right? So we also have, again, our quadratic expression, which is 1x squared plus 1x plus 2. We know we can't factor it because our last two are imaginary or complex. So we go right into quadratic formula. Bless you. So we'd have x equals -1 plus or minus radical 1 squared. Anybody want to help our boy there? Man, not won any popularity contests or anything. I'm just kidding. See you, buddy. 4 times 1 times 2 over 2 times 1. As we clean it up, we'd have -1 plus or minus something over 2. So 1 squared basically is 1 minus 8 would be -7. So the square root of -7, that's where our imaginary number comes into play. So we have -1/2 plus or minus square root of 7 over 2 times I. So that's our last 2. Okay. Anybody have any questions, comments, concerns? Hopefully this helps. And we don't really have time to talk about that little bonus question I added. I'll try to bring that back around when we think about, like, what could we do to solve that.